Construction work is a regular contender for the title of most dangerous job. The top causes of injury and death have even earned their own dark category, the Fatal Four. There's falling, possibly from a great height. There's being struck by an object, which could also be falling from a great height. There's electrocution, and there's something called caught in between, getting pinched or crushed between, say, equipment and a wall, or between two steel beams, and on in countless combinations. Hands are often the unfortunate victims. On a construction site, almost everything can turn against workers. Tools become projectiles and unintentional weapons. A moment of inattention can turn into a long nightmare of pain, disability, and recovery. The toll in human suffering is impossible to reckon, but in the cold calculus of financial loss, the cost of on-the-job injuries and fatalities reaches tens of billions of dollars every year. There is some good news. The injury rate declined steadily from the early 90s until about 2007. But since then, it's kind of leveled off.
And that plateau, we think, is predominantly due to the fact that we have eliminated the lower severity incidents. But now we are in a position where we are struggling to eliminate lower frequency but higher severity injuries.
That's John Gambatese, a professor of civil and construction engineering. Before joining academia, he was an engineer in the San Francisco Bay Area, where he evaluated and designed systems to guard structures against earthquakes. For much of his career since then, he's focused on making construction work safer. Early in our conversation, John said something I didn't expect. The construction industry knows how to make the job safer. Workers know too. Objectively, there's no good reason why the work should hover at the apex of high-danger jobs. So what's going on? I'm your host, Steve Franzel, and in this final episode of the season, which focused on health and safety, we'll get some answers to that question. We'll see how some very human traits get in the way of our own good, and we'll find out what can be done to make construction work safer. From the College of Engineering at Oregon State University, this is Engineering Out Loud.
We know how to be safe. All of us know how to be safe on the job or even in our regular life. I personally think that often we choose not to be safe for whatever reason, and it boils down to risk and reward. So if I'm going to cross a street, or I'm going to climb up a ladder, or I'm going to choose something to eat, I balance the risk of doing that action and the reward or the benefit of completing that action.
We all can relate to this simple idea. You're in a hurry. You decide to run across a busy road in the middle of the block. You've done it dozens of times, it's no big deal. But it doesn't always work out. If you get off lightly, an angry driver honks and offers you a one-handed gesture of, goodwill. You could also end up in the hospital, or worse. But we assume we're going to make it, right?
You may choose to do something in the right way, or maybe you may choose to take a shortcut because you want to get it done fast. That's the same thing on a construction site. We have competing priorities. We've got safety, cost, schedule, quality, all these things that we're trying to balance.
Yet the gulf between knowing the right thing to do and doing it every time can be huge. John gave an example of how easily our choices can change with circumstances. There is a study where workers on a building site were asked to put on a harness. The gear would prevent them from falling.
And then as part of the experiment, they said, okay, the first time we're going to do it, it will take maybe 20 minutes to go get the fall protection equipment, put it on, and then go do the work. The next time they extended it to 30 minutes. It took longer to put the fall protection equipment on and go up. And then they extended it to maybe 40 minutes. And what they found was that the more time it took to put on that safety control, the workers were discounting the risk.
So the longer it took to prepare for the task, the more likely workers were to go ahead and start the job without putting on the gear. What changed? Well, it's all in our heads.
About 90% of the incidents are related to human behavior. About 10% is related to the working site conditions, and then a certain percentage related to perhaps acts of God.
Wherever an accident occurs, the cause will almost always come down to human foibles. Take your pick. Forgetfulness, distraction, overconfidence, time pressure, money, ignorance, stress, fatigue, stubbornness, or just the mindset of, that stuff doesn't happen to me. But it does, and when it does, it's usually because we made bad decisions despite good intentions.
As humans, we make mistakes and we have certain behavior. We can all relate to the occasional incident at home where we get injured, unfortunately, and that's the same thing that happens on the construction site.
John is not just a pessimist full of dire warnings. He brings answers, too. To put them in some context, it helps to start with a system of ranking or categorizing solutions. One system used in many industries is called the hierarchy of controls.
In safety management, safety engineering, we have different ways to address a hazard. So we have a hazard on a site. Maybe it's a place where we could fall. And then we ask the question, well, how can we control that hazard? And the hierarchy of controls is something that guides us.
You don't need to get caught up in the jargon. The idea is straightforward. Think of a bookshelf with 4 or 5 shelves. On the lowest shelf are the simplest and least expensive answers, but they're also the least reliable. Each time you move to a higher shelf, the available methods become more effective, but also more costly and more complicated. An example of low-level hazard protection is a harness to prevent falls, just like the one in that risk perception study we talked about a few minutes ago. The worker puts it on and clips it into an anchor point, kind of like a rock climber would. It will stop the worker from falling, if it's used. That variable is why the harness is considered somewhat unreliable. The worker has to take action. It's like your seatbelt. It can save your life, but only if you buckle up. Moving higher, you get things like warning signs and worker training. Further up the hierarchy are physical barriers like guardrails. The presence of a barrier means that workers don't have to make a conscious choice to avoid harm. That's a good thing. It means one less distraction. An airbag is somewhat equivalent. It's just there, standing guard, so to speak. At the top of the hierarchy is hazard elimination, getting rid of the source of danger itself.
The best thing that you can do is to remove the hazard from the site.
It's also the most complicated way to go. It requires a lot of planning, and it calls for a fundamental shift in how designers and builders view safety in the grand plan of big construction projects. Hazard elimination lies at the core of an overarching safety philosophy that John has advocated for years. It's called prevention through design.
So prevention through design, a very big topic that says, I recognize the hierarchy of controls, and I would like to eliminate the hazard if we can. I'm going to design that building, bridge, or roadway in such a way that the hazards are not present on the site. So an example of that is if I have a building and I choose whether to put a skylight in the building. A skylight is nice, right? It lets in light. It opens up the working area. It provides a nice working space and so forth. The skylight provides a safety hazard or creates a safety hazard for the workers while they are building that facility. And even for people who are maintaining the facility after, if they have to go up on the roof. If they step on the skylight, perhaps they might fall through the skylight. And so prevention through design says, well, let's try not to have that skylight and design it out of the building so that that hazard is not present.
And if the builder really, really wants that skylight, the solution might call for additional safety features, like strong metal mesh over the glass. In other areas of the worksite, the measures could include built-in anchor points to hook in safety harnesses, parapets around the perimeter of a roof, ladders and work platforms that are bolted on to the steel frame so that workers can safely travel across narrow, exposed beams. The practice is not limited to structural elements. It can address things like reducing toxic asphalt fumes or reducing noise at its source rather than relying on personal hearing protection. The whole idea of prevention through design, though, can be a tough sell.
So there have been a number of studies that have tried to track the design of a building or a bridge to the safety during construction. It's very hard. It's hard to connect the design to an incident. But when we've been able to do that, we have seen benefits in lower levels of risk. We've seen increases in quality and production of the work because the worker no longer is distracted by the safety hazard. They can concentrate on their work. They can do it faster as well.
Prevention through design is common in Europe and some other parts of the world, but it hasn't gained much traction in the U.S. Considering the potential upside, the question is why?
Yeah, a very good question, something we're scratching our heads about. Applying prevention through design is not very common in the construction industry in the U.S. And there are a number of reasons for that. One of them is essentially the lack of training for engineers and architects in terms of safety. It's often not part of their curricula at the university.
And ironically, builders worry that by designing safety features into their plans, they actually expose themselves to liability if an injury does occur during construction.
So a lot of the architects and engineers kind of step back from safety and don't get involved in safety for that reason.
There are practical reasons as well.
It's very difficult to identify what the hazards might be when I'm looking at the computer screen of a big facility before it is built. Can I foresee what the hazards are? And then if I cannot, it's hard to design them out. One other one that comes into play a lot is if I am an architect or an engineer, I might recognize a hazard. I can create a design that eliminates that hazard, but maybe that design creates the building aesthetics that I don't like. And so you have this competing priority between safety, cost, aesthetics, quality, and other things.
Finally, there's the very American aversion to regulation.
But here in the U.S., we have gone a different route where we have said, let's not regulate it at this point. Let's try to incorporate it into our standard practices and procedures. And then later on, once we've done that, maybe we can develop a regulation. But I don't think that will happen anytime soon.
John has put in a lot of time and effort educating the industry. It's challenging, but he believes he's making an impact.
I've been involved with prevention through design for almost 25 years. So over the years, it's been slow, but we continue to develop new products, new practical tools to assist people. We continue to give workshops and seminars, and it's slowly increasing interest.
In fact, a week or so before this episode came out, John gave a workshop to a company in Washington, D.C. Then he stopped in at Congressman Peter DeFazio's office to talk about getting research funding for a very different type of construction site danger. It's called work zone intrusion. Anytime you drive by a road crew, you're looking at a very perilous situation.
There are public vehicles driving right by the work zone because we don't want to close down the roadway. And obviously that creates a safety hazard for everybody, including the driver.
The Oregon Department of Transportation, or ODOT, posted a chilling video about one close call. When a tractor-trailer burned out its brakes on a long I-5 downhill, the driver lost control and veered into a work area at 80 miles an hour. Some of the workers felt a blast of air as the truck rocketed by before they even knew what happened. They were lucky and no one was hurt. But the outcome isn't always so good, and plenty of workers have been killed or seriously injured by intrusions. You can find a link to that video in the show notes on our website, by the way. ODOT asked John to evaluate some proposed solutions that are designed to keep work zones safe. They range from simple time-tested interventions like lights and barriers to high-tech networked systems that might be able to actually predict an intrusion and buy some time for workers to reach protected areas.
One of the controls that we are investigating currently is the use of flashing blue lights on the equipment. Sometimes when we place a police car in the work zone, that is a very, very effective control. The idea here is to mimic that control, put the blue lights on the piece of equipment. So when a driver sees the blue lights, they will interpret it perhaps as being law enforcement and slow down.
Police aren't thrilled about this. They worry that drivers could become desensitized to the urgency of flashing lights on a police cruiser speeding to an emergency.
In many states, flashing blue lights are reserved for emergency vehicles, and blue is typically reserved for law enforcement. The concern is long-term, how will that affect the driver's behavior when they do see a law enforcement vehicle? So some of the research that we were asked to do here was to investigate the implications of using a flashing blue light in the work zone.
Even those signs that flash your actual speed and kind of shame you into slowing down are somewhat effective. Then there are those big concrete barriers along the perimeter of the work zone. They create a potent line of defense between workers and traffic, but they aren't always practical. They're big, they're heavy, and the roadway might be too narrow to accommodate them. They can't be used where there's cross traffic or if vehicles need to change lanes. They're also very expensive, and it takes a long time to install and move them. The future is decidedly oriented toward high-tech solutions.
So an example of that would be some type of system where if there is an intrusion into the work zone, a signal is sent to the workers either via some device that they are wearing. Maybe it vibrates, or maybe there's a loud alarm, or maybe there's a light that goes off to say there's a car intruding into the work zone, get out of the way. Some of them work well, some of them have their drawbacks. What we're going to see in the future is the use of more technologies that give real-time information to the driver, technologies that connect the driver to the work zone, what's happening, technologies that provide information to cars upstream of the work zone to alert them that maybe there's a queue of vehicles waiting to get through, so slow down sooner. Automated flagging stations, so you don't have to put a flagger there. Maybe a technology that allows workers to perform the work remotely from the shoulder rather than in the work zone, or autonomous construction equipment that runs on its own out in the lane and workers are off-site. Implementation of technologies is really what we're looking at in the future.
This episode was produced and hosted by me, Steve Franzel, with additional audio editing by Molly Ayton. Our executive producer is Jens Odegaard, and our technical director is Rachel Robertson. Our intro music is The Ether Bunny by Eyes Closed Audio on SoundCloud and used with permission of a Creative Commons Attribution license. Other music and effects in this episode were also used with appropriate licenses. You can find the links on our website. For more episodes, visit engineeringoutloud.oregonstate.edu or subscribe by searching Engineering Out Loud on your favorite podcast app. Bye now.
When the interviewer says, "Thank you, John, for your candid interview there," the person who was being interviewed always says, "Thank you." They never say, "You're welcome." I don't know why people tend to do that.
Thank you, John.
And you're welcome.